when we do statistics on binomials, what we actually usually do are statistics on proportion. So I just want to point that out now. We don't usually talk about, oh, I got 60, I found 60 smokers in my 200 cases. We don't usually talk about the number 60. We talk about the proportion, that that's 30% of my sample. So our statistics are all going to be on the proportions rather than the counts. So you'll just notice when we do statistics on proportions, it'll look a lot like the binomial, but everything will differ by a factor of n. So a statistic on a proportion, when I represent that as a p hat, that means a sample proportion. If I want to know what's the mean and standard deviation of a sample proportion, those fall right out of the binomial, the mean and variance for a binomial. So the mean is just p. That's np for a binomial divided by n, because a proportion divides by n. That's the mean for a proportion is p. And similarly, the standard deviation for the binomial is the square root of n times p times 1 minus p. If you divide that quantity by n, it turns out to be this lower quantity. And we're going to see this particular formula a lot because that's the standard error of a proportion. So again, that formula is going to come up, but it falls right out of the binomial. And when we're doing statistics on proportions, we're actually usually calculating z-scores. We're actually pretending we're on a normal as long as the original binomial, the n times p is greater than 5. So most of those statistics on proportions have that assumption embedded in them that n times p is greater than 5. If it turns out that you have a situation where you have n times p is less than 5, that often occurs if you have a very small sample, you need to instead go back to calculating the exact binomial probabilities, and those tests they are just what they sound like. They are named things like the exact binomial test. So we'll see some of those in the case where you might have small numbers and it's not appropriate to approximate with a normal.